So there's our question. The shortest distance from a point to a line in R3, it could be in R2, it really doesn't matter which space it's in. The formula applies equally well to everything. So for example, here's an example I made up. Suppose you have a line given in parametric form, and its x equals 102 plus lambda 110. So 110 is the vector direction of the line, and 102 is one point on the line. That's the position vector of a point on the line. And lambda is a real number. So as lambda goes through all the real numbers, that's the whole line. And we want to find the shortest distance from that point 301 to that line. So let's get a decent pen color here. So really we're looking for this distance there. That's D, that distance there. Now one point on the line is going to be this point here, which is 1, 0, 2. That's a point on the line. We need that because we're going to use our projection formula. We're going to find that vector right there, and we are going to project that onto this direction here. We're going to find that vector there. So we'll call this point A, we'll call that point B. We're going to find AB. AB is going to be the projection of AP along that line. Now that line has direction B, call it B, or maybe not, B is a bad letter, we'll call it U, okay? So U goes in that direction. We're projecting AP along U to do this. And once we've done that, once we've found AB, we just use Pythagoras to find D because it's a right angle triangle, simple. So let's get going with that. Let's find the projection. So AP, pardon me, AB is the projection, proj, of AP along U. I've explained this formula elsewhere, so I won't explain it now. We'll go here, see other video. I'll just write the formula out now. It's going to be AP dot product. We also explained dot product in the other video, over U squared, the magnitude of U squared in the direction of U. If we apply that, we've got AP. We need to find AP. So let's do the AP over here in a different little color. Let's get a decent size of a pen. I will do AP is equal to 301 minus 102. So we're just measuring what direction from one point to another, what changes there are. So in the X direction, there's a 2. Then that's a 0, isn't it? So that's 0. And it's minus 1 in the Z direction. That is AP. So then we go, okay, 2, 0, minus 1, dot, U is just 110, divided by the magnitude of U squared. So that's 1 squared plus 1 squared plus 0 squared. Square root squared, so there's no square root. Then you put in that U. Dot product is 2 times 1 plus 0 times 1 plus minus 1 times 0 over 2 equals, let's see what that's going to be. Oh, it looks like it's just 110, easy peasy. Okay, so that's step 1 here. I might be running out of space there. So let's just go to step 2. So we're going to have, let's find the magnitude of that vector while we're at it. So the magnitude of AB is equal to root 2. The magnitude of AP is equal to 4 plus 1 plus 0 square root. So that's root 5. So we can actually do our calculation right now if we wanted to. Let's do it in a different color down there. Be daring. Let's put it into the little box. It's a right angle triangle, so we've got this right angle triangle here. Is that going to be too small? I'll put it here. There's our little right angle triangle. That's our P. That's our B, and that's our A. That's root 5, that's root 2, and that's D. So you've got D squared using Pythagoras is root 5 squared minus root 2 squared, which is equal to 5 minus 2 equals 3. 3 units is the answer, unless I've made some horrendous error. Now I'm going to squish that down a bit so you can see the whole thing. If you wanted to take a snapshot of that. Okay, whoops, a bit bigger. Here you go. Does that make sense? Shortest distance from a point to a line using the projection formula. And don't forget that projection formula there, you can find another video, a short one, which explains that. All right, guys, let's call that one